Good morning. Happy April Fool's Day. Okay, so a couple things that I need to remind you of is number one, from 2 to 2:30 today, I will be available for taking PFAs for math analysis. Please read the email I sent yesterday. It has all of the guidelines that I'm requiring, and you do need to accept the Zoom invitation I sent regarding taking those PFAs. So there's the first thing. Second thing, I sent another email yesterday with 2 attachments that you'll need to be able to use for the rest of this unit. One attachment is basically the basic forms of some of these conic sections we're going to talk about. And the other one is a nice visual of where the different values come from in the conic sections. And you can use those while you're doing your homework as a pretty quick reference. All right, so today the notes are rather lengthy. I'm going to apologize for that. But I decided what I would do is go ahead and just complete all of the notes today. They'll probably take us a good 45 minutes. And then tomorrow I'm just going to give you a work day. So you can go and start on the worksheet if you want to. Otherwise, tomorrow is just going to be an open work day, other than another time tomorrow afternoon to take PFAs if you want to. Lastly, as far as the performance task is involved for the last unit, I sent an email to those of you that were ready for it. I asked you to respond letting me know when you wanted to take it, but I've only received 2 responses. So thank you, Cameron and Adam, for that. Those of you that still have red checkpoints, once you get all those taken care of, then you will be able to get the performance task. So you need to try to stay caught up. If you get too far behind, it's going to be rough. All right, so today we are looking at the world of an ellipse. So in your world, an ellipse is an oval. So yesterday we looked at a circle, and remember these are all cross sections of cones or conic sections. So in a circle, you get a circle if you just take a piece of paper or a piece of wood or a piece of metal, and if you put that piece of wood straight through the conic section, then you get something that's parallel to the base that just creates another circle. Okay, so this one, if you take that same piece of metal and you put it through the conic section diagonally, then you get the oval shape, or what's called an ellipse. Okay, so we're going to look at ellipses today. We got a lot of lead-in notes talking about the different parts of an ellipse. Some of you may have seen these conic sections in college algebra, but if you're coming out of trig, I doubt that you've seen these before unless you've researched them on your own. All right, so you can have ellipses that are elongated horizontally, or you can have ellipses elongated vertically. Okay, so we're going to look at the horizontal ellipse first. Okay, so you have a major and a minor axis in each ellipse. Okay, so in a horizontal ellipse, the major axis is horizontal. The minor axis is vertical. Okay, so standard form of a horizontal ellipse is going to look like this. We have x minus h quantity squared plus y minus k quantity squared. The x minus h is over a value called a squared, and the y minus k is over a value called b squared, and this is always equal to 1 in the world of ellipses. So from here, the center of the ellipse is just like it was when a circle, HK. In this case, in all cases, A is always greater than B. So when you're looking at the form of this one, the A is under the X term. So your major axis is horizontal. Your minor axis is vertical. So you always look for which term is the largest, and wherever the a squared is, that tells you whether this is a horizontal ellipse or a vertical ellipse. So a squared is under the x minus h squared. So major axis is horizontal. All right. So next one, we're looking at an ellipse that is a vertical ellipse. So in this case, your major axis is vertical. Your minor axis is horizontal. Your center is where those two things cross. So standard form is going to be the same in the numerators, x minus h squared plus y minus k squared. But since this is horizontal, your a squared is under the y, and your b squared is under the x. So since your major axis is vertical, your largest denominator has to be underneath that term. Okay, so I still have my center at HK. A is greater than B. So since A is underneath my y-axis, this is my major, this is my minor. Okay, so real quick summary, look to see which denominator is the largest. The largest denominator, if it sits under the y term, then you have a major axis that's vertical. If it sits under the x term, then you have a major axis that's horizontal. Okay, so there's the number one characteristic that you look at. All right, so major axes and its vertices or its endpoints. All right, so here is my vertical ellipse. So remember that largest term would be sitting under the y minus k. So here's my center at HK. These are my vertices. Where does that major axis meet the ellipse? This is my A value right here, or down below. Okay, so for this case, my vertice, my H isn't changing because I'm not looking left or right. That major axis is going up or down, so it's going to affect the K value. So in this case, my vertices would be found by leaving my H and taking my K plus or minus the A value. So that's going vertical since that's my Y coordinate of my center. So same idea over here. If I have a horizontal major axis, my HK is my center. My vertices are going to sit at the end of that major axis. My A value is from the vertice to the center. So in this case, it's changing the X value or the H value of that center. So my vertice is at H plus or minus A, and my K is not changing. That's going to be my minor axis vertices. I should say vertices, not vertical. So you'll see how that's all applied here in a bit when we actually do an example. Okay, so your A value is always added or subtracted to either the XY value, X or Y value of the center, depending on if it's a horizontal or a vertical ellipse. All right, so your minor axis and the co-vertices. So the co-vertices are on the ends of the minor axis. So in this case, for this vertical ellipse, my minor axis is horizontal. This is still my HK. Here are the vertices of that minor axis. And this is going to be affected by the B value. So remember, you have a B squared in your standard form. So the square root of that becomes your B value. So since this is horizontal, it's going to be affecting my H term. So my co-vertices would be H plus or minus whatever that B value is. And the K value is going to stay the same. These are called my co-vertices. Okay, so in a horizontal ellipse, here's my center at HK. My B value is from the center to the vertice. So this one is going to affect the K value. So my minor axis is vertical. So my H value is going to stay the same. And I'm going to take K plus or minus B. Okay, so remember your minor axis, the vertices, you actually add that A value to either the H or the K, depending on if it's horizontal or vertical. And for your minor axes, you use the B value. And to determine your vertices, you have to decide if you're going to add that to the H or K, depending on if it's horizontal or vertical. All right, so the last piece of an ellipse is called the foci. So the foci sits on either the major axis of a vertical ellipse or a horizontal ellipse, and it sits just, the foci points sit just inside the vertice. So in this case, I have my HK at the center. Remember, I had my vertices here. Okay, so my foci is a point that sits on that major axis just inside those vertices of your major axis. Okay, so for your foci, you have your C value. And you'll figure out how to calculate all these A's, B's, and C's here in a minute. Okay, so this is vertical, so it's going to be affected by the C value, and it's going to affect that Y term or that K term. So I'm going to have my H term is going to stay the same, and my K is going to be plus or minus that C value. Okay, so it sits on the vertical axis, since it's a vertical ellipse. Okay, so same idea over here. I have my HK. I have my vertices that sit out here. And then I have my foci that sits inside on that major axis. So this right here is my C value. So in this one, my H value is going to be affected. So H plus or minus C. K stays the same. Horizontal. Okay, so for a little note here, we don't really go into where this formula comes from, but C squared is always equal to A squared minus B squared. So remember, this is your major or your largest numerator. This is your minor. And it determines whether you have a horizontal or a vertical ellipse. Okay, so now the fun begins. Okay, so we're going to graph this ellipse using the center, vertices, co-vertices, and the foci. So I'm going to forewarn you, we have a lot of calculations we're going to go through on this problem. I'm going to try to use different colors to keep things straight for you. Okay, so the first thing I can find, obviously, is the center. So the center is coming from the numerator, so it's at 3, -1. Okay, so there's the first thing I can find. Okay, so the second thing I can find is this a horizontal or a vertical ellipse? And since this is my largest denominator and it's sitting underneath the y term, then this is a vertical ellipse. So from there, I know that 9 is the a value, not a squared value. So I know a is equal to 3. I'm going to need that to calculate my vertices. B squared is equal to 4. So B is equal to 2. Okay, so there's the second thing I can calculate. So keep in mind, my major axis is vertical. I'll go back and write that up. My minor axis is horizontal. Okay, so let's calculate our vertices. So the vertices are on the major axis. Which, remember, that was our y-axis, so that's going to affect the k value of the center. So my vertices are going to be at 3. My k value is -1, plus or minus that a value, which is 3. So my vertices are at the point 3. -1 plus 3 is 2. And 3. -1 minus 3 is -4. So that gives me the endpoints where the major axis meets the ellipse. All right, I haven't used blue, so co-vertices. Okay, so my co-vertices are on my minor axis, which in this case is my x-axis, because my major axis was vertical. So this is where I use my b value. So my co-vertices are at 3 plus or minus 2, comma 1. So my center is staying the same as far as the y value. My co-vertices are going to give me my endpoints of my minor axis. So I have 3 plus 2, which is 5, -1, and 3 minus 2, which is 1, -1. Okay, so last thing I need is my foci. That's where I use my C value. So first thing I got to calculate is what is C equal to. So C squared is equal to A squared minus B squared. So C squared is equal to 9 minus 4. C squared equals 5. So is equal to plus or minus the square root of 5. So we're going to leave that exact. And in order to get the point in close to the right place, all we have to do is think of 5 is a little more than the square root of 4, so it's a little more than 2. When we're graphing those points. Okay, so the foci is on the major axis. And again, remember this is our y-axis. So we're going to take our center, which was 3, -1. Major axis is y. So my h value stays the same. My k value is what's changing. And we're going to leave that just like that, and I'll show you how to use it on the graph. Okay, so we have everything we need. Just got to get back to the right colors. So I have a center at 3, -1. I have vertices at 3, 2. And 3, -4. I've got my center one too far down. Pretty bad when you screw up the very first part of this. I knew something didn't look right. Okay, so vertices, sorry about that, 3, -4. And that's wrong too. Whew, can't count. Okay, so my co-vertices, see if I can get these right. All right, 5, -1, 3, 4, 5, -1, and 1, -1. Got those right. So then my my foci is at -1 plus or minus about 2. So the way I do this is I just remember I'm adding or subtracting the square root of 5, which is pretty close to 2. So I go to my center and I just add a little bit more than 2 for my foci. And I add a little bit more than 2. So my foci sit just between the vertice and the integer right above it. So now if I'm to sketch my graph or my ellipse, this is always tedious because I'm not very good at drawing these. It looks like that. So since your A value and your B value are pretty close together over here, you get something that's pretty close to a circle because those axes are just off by 1 unit. If you had a circle, your A value and your B value would be the same. All right, so that took a little bit of time. Okay, actually, I've changed my mind. We're just going to go through one more example, and then you can work on the parts of the worksheet that you can do, and then I'll finish the examples tomorrow. How's that for a deal? April Fools, no 60 minutes worth of notes today. You're welcome. All right, let's get through this one. All right, so on this one, my major axis is horizontal. There's my largest number underneath the X value. Okay, so my center for this one is at -2, 4. My major axis is horizontal. So I know that now I've got to calculate my A values, my B values, and my C values. Okay, so this is A squared, and this is B squared. Remember, A squared is always the largest because A is greater than B. Okay, so A squared is equal to 49. A equals 7. B squared equals 25. So B equals 5. Okay, so vertices. Okay, so vertices lie on the major axis, which in this case is my x-axis. So this will be affecting my h value. So my vertices are going to be at -2. And I have to add a, so plus or minus 7. My k value of my center doesn't change. So I get -2 plus 7, which is 5, 4. And I get -2 minus 7, which is -9, 4. Okay, so covertices. It's kind of like when you're doing these, you have to have the same thought process as you go through it. So this one is my y minor axis. So this is going to be affecting my k value of my center. So my h value stays the same. And my center 4 is plus or minus b. So my vertices are co-vertices are sitting at -2, 4 plus 5 is 9. And 4 minus -2, 4 minus 5, which is -1. Okay, so last thing is foci. So we have to calculate that C value. So C squared equals A squared minus B squared. So 49 minus 25. C squared is equal to 24. C is equal to plus or minus the square root of 24, which is close to 5. So if you look up here, your B value is 5. So that foci is sitting just inside those covertices, or those vertices, I'm sorry. Okay, so that is affecting your x value because we have a horizontal ellipse. So the coordinates of your foci are -2 plus or minus the square root of 24. So it's affecting your major axis, which lies on the h value of the center. And your k value is not going to change. So when I do this, I just take once I get my center graphed at -2, 4, I just count up almost 5 units to get to that foci. Okay, so that's a term you kind of need to get used to because it's going to happen in hyperbolas too when we get there. Okay, let's graph. So we have a center at -2, 4. I have vertices at 5, 4, 1, 2, 3, 4, 5, 4, and -9, 4. I have co-vertices at -2, 9. Right here. I should be in green. And -2, -1. Okay, so for my foci points, I am going to go on my major axis, which is horizontal. I'm going to go from the center, and I'm going to count about 5 units. So 1, 2, 3, 4, 5. It's going to sit in here. And -2, 1, 2, 3, 4, 5. So not quite 5. Lost my pen. 1, 2, 3, 4. Okay, sketch. So again, this one is somewhat close to a circle, not quite as close as the last one because your A value and your B value are so close together. Okay, so if you look at the handouts, that second one that has more than just the formulas on it, it pretty much gives you a picture of the ellipse and all the other ones we're going to cover. And it tells you like where to find the A value, the B value, the C value, how to calculate those things. So pretty much if you go through the same process for all of these, it's not that bad. It's just a matter of thought and how you're doing things. Okay, so I'm going to stop because we probably have a good 25 minutes left of notes. So go ahead and get started on the worksheet. It reviews circles at the beginning and then it does some ellipse stuff. So tomorrow I'll finish the notes and we'll go from there. Have a wonderful April Fool's Day.